Hello children, good morning. Today I will start the chapter The Force and Laws of Motion. Before start the lesson, let us recall the few concepts which I have learnt in the previous class. You have studied about motion and types of motion in the previous class. What is motion? The motion is nothing but the movement of objects. We can study about the motion of the objects as a branch of physics called mechanics. So, mechanics is a branch of physics which deals with the study of the motion of the objects. Mechanics is classified into three branches. The first one is statics and second one is kinematics and third one is dynamics. In statics, we will study about the object at rest. So, the statics is a branch of mechanics which deals with the study of the objects at rest. In kinematics, we will study about the motion of the objects without considering the causes of the motion. So, kinematics is a branch of mechanics which deals with the study of the motion of the objects without considering the causes of motion. In the previous chapter motion, you have studied about speed, velocity and the acceleration without considering the causes of motion. And the next one is dynamics. In dynamics, we will study about the motion of the objects by considering the causes of the motion. So, the dynamics is a branch of mechanics which deals with the study of the motion of the objects by considering the causes of motion. So, the mechanics is a branch of physics which deals with the study of the motion of the objects. Mechanics is classified into three branches: statics, kinematics and the dynamics. So, statics is a branch of mechanics which deals with the study of the objects at rest, and kinematics is a branch of mechanics which deals with the study of the motion of the objects without considering the causes of motion, and dynamics is a branch of mechanics which deals with the study of the motion of the objects by considering the causes of the motion. In this chapter, we will study about the causes of motion. You know, every object in nature is either in a state of rest or motion. The motion may be uniform or non-uniform. In order to bring a moving object to rest or to make a stationary object move, we must push, pull or hit it. For example, consider a spring. Now, pull the spring on both the sides. When you pull the spring on both the sides, you find that the spring will expand. Next, consider a rolling ball on the floor. Now, keep a bat at certain angle in the path of the rolling ball. When you keep a bat at certain angle in the path of the rolling ball, then you find that the ball changes its direction of motion when it hits the bat. Next, consider a rubber ball and press it. You find that the shape of the ball is deformed. Next, consider a ball lying on the floor. The ball remains at rest until we are pushing it. When we push the ball begins to move. The ball begins to move in a straight line with some speed. So, when you pull the spring on both the sides, the spring will expand. When you keep a bat at a certain angle in the path of the rolling ball, then the ball changes its direction when it strikes the bat. And when you press a rubber ball, the shape of the ball is deformed, and when you push a ball lying on the floor, then the ball begins to move with some speed. From these examples, we know that the push, pull or hit acting on your body changes the speed of the body or direction of motion of the body or shape and size of the body. Therefore, the push or pull acting on the body is called force. Force can change the state of motion of the body, shape and size of an object, speed of an object, and direction of motion of an object. Now you know force and effects of force. The next is types of force. When two or more forces act on an object in different directions, then the change in its state depends upon the nature of the forces. Forces are classified into two types: balanced forces and unbalanced forces. Unbalanced forces. Now, let me know about the balanced forces. Consider a wooden block on the smooth table and apply the force F1 on one side of the block and apply an equal force F2 on the wooden block simultaneously but in the opposite direction of F1. Here the force F1 and F2 are equal but acting in the opposite direction on the block. Since F1 and F2 are equal but acting in the opposite direction, then the net force acting on the block is 0. Since the net force acting on the block is 0, the block does not move, it remains at rest. Such forces acting on the block are called balanced forces. Therefore, when two equal and opposite forces acting on an object simultaneously, then the object continues in the state of rest or of uniform motion along a straight line. Such forces acting on the object are called balanced forces. For example, when we push the wall does not move. When we push the wall, the force of push F1 acts on the wall in the forward direction. On the other hand, the wall exerts an equal amount of force F2 on our hand in the backward direction. Here, the force of push F1 and the force exerted by the wall on our hand are equal, but they are acting in the opposite direction. Since F1 and F2 are equal but acting in the opposite direction, then the net force acting on the wall is 0. Since the net force acting on the wall is 0, then the wall does not move. It means it remains at rest. So such forces acting on the wall are called balanced forces. Another example. When a child pushes the box does not move. The force of push applied by the child on the box acts in the forward direction. The force of friction acts in the backward direction opposite to the direction of the motion of the box. The force of friction acts in the backward direction and it opposes the motion of the box. And the force of push applied by the child is balanced by the force of friction. So the net force acting on the box is 0. The net force is 0. So the box does not move. It remains at rest. Next, let us know about the unbalanced forces. Consider a wooden block on the smooth table and apply the force F1 on one side of the block. At the same time, apply the force F2 greater than F1 in the direction opposite to F1. Here, F1 and F2 are the two unequal forces acting on the wooden block in the opposite direction. Since F1 and F2 are unequal forces but acting in the opposite direction, then the net force acting on the block is net force acting on the block is F2 minus F1. Since the net unbalanced force acting on the block is F2 minus F1, then the wooden block moves in the direction of the larger force F2. So, the such forces acting on the block are called unbalanced forces. Unbalanced forces. Therefore, when two unequal and opposite forces acting on an object simultaneously, then the object moves in the direction of the larger force. Such forces acting on an object are called unbalanced forces. For example, consider a tug of war. In the tug of war, two teams are applying the forces on the rope in opposite directions. If team A is stronger than the team B, then the force F1 is greater than the force F2. Therefore, the net unbalanced force acting on the rope is F1 minus F2. Therefore, the rope moves in the direction of the larger force F1. Such forces acting on the rope are called unbalanced forces. Another example, when you are riding a bicycle, if you apply a small force on the pedal, then the bicycle will not move. Here, the small force applied by the rider is balanced by the force of friction exerted by the road on the tire in the opposite direction of the bicycle. Here, the force of rider and the force of friction both are balanced, so the net force is 0, so the bicycle will not move. In order to make the bicycle moving continuously, we have to apply the more force on the pedal. When you apply the more force on the pedal, then the net unbalanced force is the difference of force of rider minus force of friction. Therefore, in order to keep the bicycle moving, you have to paddling the bicycle continuously to maintain an unbalanced force in the direction of motion. Now you know balanced and unbalanced forces. Balanced forces means when two equal and opposite forces acting on an object simultaneously, then the object continues in the state of rest or of uniform motion in a straight line. Such forces acting on the object are called balanced forces. And unbalanced force means when two unequal and opposite forces acting on an object simultaneously, then the object moves in the direction of the large force. Such forces acting on an object are called unbalanced forces. Therefore, balanced forces acting on an object does not change the state of motion of the object, but unbalanced forces acting on an object changes the state of motion of the object. Next, let us know about the Newton's laws of motion. You know, when force is acting on an object, it changes the state of motion of the object. Newton established the relationship between the change of state and the force responsible for this change in the form of 3 laws. These 3 laws are known as Newton's laws of motion. Newton's first law of motion states that every body continues in the state of rest or uniform motion along a straight line unless it is compelled by an external force to change that state. It means A body at rest remains at rest unless it is compelled by some external force to move. For example, a book lying on a table remains there unless it is lifted by someone. And a moving body will continue to move in the same direction unless some external force stops it. For example, moving bus continue to move until the driver is applying the brake. Therefore, the internal forces acting within the body opposes any change in the state of the body. From Newton's first law of motion, it is clear that a body is unable to change its state of rest or motion by itself. This property of the body is known as inertia. Therefore, the tendency of a body to oppose or resist any change in its state of rest or uniform motion is called inertia of the body. And inertia is the inherent property of all the objects. Therefore, Newton's first law of motion is also called as the law of inertia. Now you know what is inertia. The next is types of inertia. Inertia can be divided into three types: inertia of rest, inertia of motion, and inertia of direction. Next, what is inertia of rest? The tendency of a body to remain at rest is called inertia of rest. For example, when a bus suddenly starts moving forward, the passengers in the bus falls backward because the lower part of the body of the passengers being in contact with the floor of the bus come in motion along with the bus, but the upper part of the body of the passengers remains at rest due to inertia of rest. Therefore, the passenger falls backward. Another example, the carpet is beaten with a stick to remove the dust particles. When the carpet is beaten with stick, the fibers of the carpet come in motion along with the stick, hence they move forward. But the dust particles remain at rest due to inertia of rest, therefore they fall down. The next is inertia of motion. The tendency of a body to maintain its motion in the same direction is called inertia of motion. For example, the passenger fall forward when a fast moving bus stops suddenly because the lower part of the body of the passengers being in contact with the floor of the bus come to rest as soon as the bus stops. But the upper part of his body continue to move forward due to inertia of motion. Therefore, the passenger falls forward. Another example, a luggage is usually tied with a rope on the roof of buses because when a moving bus suddenly stops, the luggage on its roof continue to move forward due to inertia of motion. Therefore, the luggage fall down from the roof of the bus. To avoid the falling of the luggage, it is tied with a rope on the roof of buses. Next is inertia of direction. The tendency of a body to continue in the same direction is called inertia of direction. For example, tie a stone to a string and rotate it. Then, when you release the string, the stone moves in the direction tangent to the circular path. Here, tangent means it is a straight line that touches the circle at only one point and perpendicular to the radius. You know, when the object is moving along the circular path, it changes its direction at every point along the circular path. Therefore, the tangent drawn at any point along the circular path shows the direction of the object at that point. Therefore, when you release the string, the stone moves tangentially to the circular path. Another example, you know the sparks produced during sharpening of a knife against a grinding wheel leave the rim of the wheel tangentially because of the inertia of direction. Now you know what is inertia and types of inertia. The tendency of a body to oppose any change in its state of rest or uniform motion is called inertia of the body. Inertia of the body is divided into three types: inertia of rest, inertia of motion, and inertia of direction. The tendency of a body to remain at rest is called inertia of rest, and the tendency of a body to maintain its motion in the same direction is called inertia of motion, and the tendency of a body to continue in the same direction is called inertia of direction. Okay children, let us continue in the next class.